All right, I gotta practice. So I asked my students to give me something to practice with, and they all said they would, then they didn't. Then I went to a specific student, and he was like, "Yeah, I'll send you something," but he never sent me anything. So I'm just gonna go ahead with triangles because I like them, and I'm gonna do this Common Core assessment, module 8, I think. No, probably. Oh, grade 8, module 7. It's like the last test of the last lesson of the last year, I guess. And just gonna. I've already started a little bit because this pen is new on this writing thing, so I gotta try my best here. And sometime during the video, I'm gonna give out a prize, and I'm not gonna say when. I'm just gonna put that out there. But so let's do some of these problems for like 10 minutes or so, and then see how much we can get through, whatever. So like question 1 is a triangle with sides 7, 24, 25 centimeters, a right triangle. Explain. Well, remember, we're talking about Pythagorean theorem, right? It wasn't mentioned, but when you want to test something, if you want to figure out if something is a right triangle, you need to know that you're going to be working with the Pythagorean theorem. And that theorem is, in case you forget, it's like a squared plus b squared equals c squared. And I've done that here. I just plugged in 7 here, put in 24 and 25. 7 times 7 was 49. I use a calculator here. I'm not that good to have memorized 24 squared and 25 squared. It comes out to 576 and 625. You add 49 and 576 together, you do get 625. And of course, 625 does equal 625. So, I mean, that was the math part, but the key here, look at that. That line was almost perfect. A little smudge right there, darn it. The key here was, though, they want you to explain this stuff. So, I kind of said that in the opening, right? Whenever you want to test for a right triangle, you just use the Pythagorean theorem. So sometimes math explanations can be like confusing because it's like the answer's right in front of your face. So you just basically say, and this is where I gotta work on my handwriting, when plugged in to the Pythagorean theorem, when plugged into the Pythag theorem, how you spell that? Theorem. Oh man, I'm lost. I'll just put theory. Values are true. This is another thing I was worried about. Bless you. Try to get 3 dots in here. There you go. Therefore, then we can say therefore the side make a right triangle. I am gonna have to. And you know what? I don't know if my handwriting is gonna get any better. Maybe there's something I can do with this pen, like make it thinner, or maybe zoom out so it doesn't look so crazy. All right, next is a triangle with sides 4, 11, 15, a right triangle. So this is basically they're just testing the same thing. So what do we have to do? Again, it's always a good idea to start with your formulas or what you know. So we know that if we're going to test side lengths, we're going to be messing with, and right triangles, we're going to be messing with the Pythagorean theorem. So we're just going to do that, and then we just need to plug in 4, 11, and 15 millimeters. So we'll just do 4 squared plus 11 squared equals 15 squared. All right, and then we know that 4 squared is 16, 11 squared is 121, and 15 squared is what? 225? I messed that up? Check that out. This is a 5, right? 5 and yeah, 2. Carry the 1. 2, 2, 5. All right, so you can kind of see already. What would be 121 plus 16? And again, just especially during a test, even if you think you could do it in your head, I wouldn't do it in my head. I would just do it on the side here, just to make sure you got it perfect. So 137 equals 225. You like that? 137 equals 225? No. So, we answer the question, no. And let's explain. Well, same thing we wrote up here. When plugged in, it was true, right? So now we want to just say the opposite. When plugged in, the values did not come out true. Or you might want to say oops, ooh, Lord, that is terrible. All right, how about you might want to say did not, getting wild, satisfy the Pythagorean theory. Okay. I'm curious, what does this look like zoomed out? I mean, much better. Like, it looks much more like a student's work. I guess that's true. Anything zoomed in, if you focus on anything in life, it's not gonna look as good all zoomed in. Little philosophy lesson with our mathematics. All right. The area of the right triangle is shown below, 30 feet squared, 30 square foot. The segment XY has a... Okay, so pro tip, man. Pro tip. They told us the segment XY has a length of 5 foot, right? So this we want to go. We really want to, as we read the problem, let's just come down right here right now and label that 5 foot. Find the length of the hypotenuse. Great. So what they did here, right, is, again, we're not dummies. We know that a 90-degree angle is going to be dealing with Pythagoras, especially when they tell us to find the hypotenuse. Because we know one side, we don't know the hypotenuse because obviously they're asking for it. So what do you need to know in the Pythagorean theorem, right? They gave us one side, we don't know that side, and then we have to find the hypotenuse. So the key here is like, okay, what tools, what have I been taught that's going to tell me the B? So, I mean, not hard. All we got to do is use the clues, right? And the only clue they gave us was that the area was 30 foot. And so we have to access something else we were taught long ago and hopefully reinforced by our teachers, is that the area of a triangle is 1/2 base times height, right? And so what do we know? We know the area. It's 30 foot. We know that a half is a half. We know our base is 5 foot. So we're just going to times 5 and then look, times height. And now, because we're older, we're smart people, we need to start using our algebra skills. And what I'm going to say here is, if, instead of like simplifying this and then, trying to divide 30 by 2.5, what I would do is I would just divide all this by 5, right? And this will cancel out. 30 divided by 5 is 6. Boom. That leaves us with half times height left over. And then, how do I get rid of this half? There's two ways, right? You could divide by a half, which is like, cool. Or, I'm hoping some of my students are paying attention, because we learned a trick. It's not a trick. You already know how to do this anyway. What we're going to do is we're just going to multiply by the inverse, or the reciprocal of 1 over 2, which is just 2. So you just multiply both sides by 2. This 2 will cancel that 2. We have a 1 and a 1 and a 1 here. So 1 times 1 times 1 is what? It's 1, right? So anyway, these cancel. I got h equals 2 times 6 is 12. Okay, so that's the first part, right? We now know that the b equals 12. Oh, feet. I guess my little ugly FT. So now, look, we're done. Pretty much, right? And we now know that our 5 squared plus 12 squared equals c squared. And then what do we got here? We have 25 plus 144 equals c squared. And then we just need to add this together. What is 1? Again, during test situations, even though you can do it in your head, I would not recommend that. So we got 169 equals c squared. And then how do you algebraically get rid of this squared or solve for c? Well, you just take the square root of everything. It'll cancel that out. And then you ask yourself what number times itself is 169, and that is 13. Right? Bam. So our hypotenuse is 13. All right. Before I do the next problem, I'm going to give you the prize. So if anybody's paying attention, here's a secret code. And then we'll figure out if anybody can figure this out. Like, what is this code? What magic beanstalk does it grow, Mr. Myrick? You tell me, using your your amazing genius. And this is open to anybody. I'm actually going to be curious who finds this first, right? Who's gonna find this PlayStation money? Boom! Just go to the PSN store, put that code in, and you will receive some PlayStation money that you can use online. Oh, look at that code there for everybody. We'll figure out who's gonna do it. All right, page 2. We'll do this one, then we'll wrap it up, and we'll see if we can get anybody to watch my video, give me some real feedback, and the ones that kind of watch it all, they will find the code. All right, 2 paths for the school to the store shown below. One uses Riverside Drive, and the other uses Cypress and Central Avenues. Which path is shorter? By about how much? Explain how you know. Okay, so we want to know the shorter path. We can see right here. And we are smart people. We know that a short path is the straight line is the shortest way to get anywhere, right? But this is a math question, and they want us to look. Here it is, the Pythagoras, right? So basically, what we're gonna have to do is we're gonna have to say, we're gonna have to use Pythagoras, and we're also gonna have to add these 2 complicated numbers up here, right? So I'll say it's a squared plus b squared equals. I always do that with my equal signs. A little trail off. All right. Versus 9 plus 7. Right. Where am I getting those numbers? I'm getting them right here. Right here. 9, 7. Oops. Okay, get rid of that. That's ugly. Oh, gotta press down. That's why we're doing this video, so we can learn. Okay, so Cypress and Central, 9 plus 6. I'm gonna change versus to or because it's less to right. 16 miles. Boom. All right, now we got to do this whole side, right? So what is our A? It doesn't matter. We'll call that A. We'll call this B. We'll call this C. And then we just need to plug it in. So we'll put our 9 here. Square it. B there. 7 squared. Oh, Lord, look at that. I'm starting to write like a drunk person. All right, edit that out of the video. This is for kids. All right, 9 squared. 9 times 9. 81 plus 7 times 7, 49 equals c squared. And then 81 again. In our head, what is that? 130. But what we want to do is we want to take no chances on a test. Make sure we get it correct. Yeah, it comes out to 130. 130 equals c. Now, squared. Now this is where we're going to take two paths. One path is for the classroom awesome student who always does everything by the book, and you know they like to do everything prim and proper. They have nice spiffy hair, maybe a fancy watch on the wrist, you know, maybe an iPhone in their hand, you know. Also, always gets A's on everything, right? Alright, then there's the other people, the rogues, man. What do? They like to play games. They like to figure stuff out, right? They like to be sneaky. They like to do things crazy. And I'm just being silly now, but we know that this route's 16 miles, right? And I know maybe we could use a calculator, or maybe our teacher taught us to, you know, spend like 10 minutes trying to figure out the square root of 130. And, you know, first of all, we know that what's 130 between? It's between 11 squared and 12 squared, right? So we could sit there and try to figure out, you know, hey, what's up? You know, where is it at exactly? But we kind of have our answer right here already. Even if it was 12, which it's not, we know that 12 squared, right? 12 squared is 144. Even if it was 144, 144 is still what? I'm sorry, 12 squared is still what? It's still less than 16 miles. So what we have here, which path is shorter? Well, answer, Riverside. Duh. Okay. Now, it says by what? It says by about how much? Well, okay. So I would say this about 4 miles. And then it says explain how you know. Well, the square root of 30 is between 11 and 12. So I would just put the square root of 30 is between 11 and 12. In Cypress to Central, or Cypress, not to, but and Central equals 16. Triple dot 16 minus 12, 4. Bam. What up? How do you draw a microphone? Is that a microphone? Drop that thing. Look, my little cool dude, my rogue. He's looking at the mic. He's dropping it. It's falling to the floor. Gonna break there. All right, that is enough. So let's see how that goes.